right, so in this presentation, we're going to go ahead and talk about the right triangular trig, if you would, or all 6 of our trig functions. Prior to this, I believe you already have discussed the 3 basic trig functions in sine, cosine, and tangent. But in this presentation, we want to talk about not only those 3, but our reciprocal trig functions. So these here in green are referred to as the reciprocal trig functions. And as you can see, they are nothing more than just taking the same relationship and just doing the reciprocal of it. So instead of opposite over hypotenuse, it's hypotenuse over opposite. These would be pronounced cosecant, secant, and cotangent. Now, in this display here, you can see a couple phrases. We have OPP for opposite, HIP for hypotenuse, and ADJ for adjacent. Those should all be familiar terms for you from your geometry days. And one of the things to point out here before we start actually going and trying to find some of these values is the fact that when we have a right triangle, one of the angles is going to be defined. All right, so we have 2 acute angles in every right triangle. One of the angles is going to be the one that we're going to be referring to calculate our trig functions. Because that's what these are. They're trig functions, which means that they actually produce a value for us. So when we take a sine function of some angle theta, it gives us a numerical value. That numerical value can be found by taking the side opposite and dividing it by the hypotenuse. That's what that's actually saying. And then so on and so forth throughout the rest of the thing. And again, that's a little bit of a geometry review. The same process is going to be holding true for our reciprocal trig functions when we get into that aspect. I also recommend laying out your work like this. That's going to pay dividends when we get later on when we start talking about trig functions, not just in right triangular trig, but coordinate trig. Let's go ahead and take a look here at our first example then. So, given the following right triangle, determine the 6 trig functions for A. So one of the things different about this triangle in comparison to our triangle at the beginning is you can see the orientation's a little bit different. That's all right. But we do want to reference that we're determining all of our trig functions based off of A. So this is where our theta value would actually be. Now that's important because we have to be able to identify then this is our opposite side, this is our adjacent side, and this is the hypotenuse. Keeping in mind the hypotenuse is always opposite to 90, and then obviously the opposite side is the side opposite the angle you're observing. So if we go here, I want to go ahead and take and find sine of theta. Well, sine is opposite over hypotenuse, but I don't know the hypotenuse yet. But this is where we have to kind of go back to our geometry roots and realize I can find the hypotenuse by doing the Pythagorean theorem. 4 squared plus square root of 20 squared equals quote unquote c squared. So this is going to give me 16 plus 20 equals c squared. 36 equals c squared. Or in other words, my hypotenuse is going to be equal to 6. Because keep in mind, the Pythagorean theorem gives us the square of the hypotenuse, and I got to take the square root of that, and that's why I get the 6. Now from here, I'm just going to go ahead and substitute in my values. So if I'm looking for the sine of theta, that's the opposite, which is square root of 20, over the hypotenuse, which is 6. If I'm looking for cosine, cosine is going to be adjacent over hypotenuse, 4 over 6, which I could also reduce to 2/3. And then I have tangent, which is opposite over adjacent, square root of 20 over 4. Now, from there, I can go ahead and I can rewrite, or I'm sorry, I can write now my reciprocal trig functions just by simply taking the reciprocal. So cosecant is going to be 6 over the square root of 20. Secant is going to be 3/2. And cotangent would be 4 over the square root of 20. Note that we're going to be allowed to actually leave our radicals in the denominator such that it's actually easier for us to identify what side we're actually using. Now another thing from here, you would see that it would have reduced the cosine to 2/3. We could also identify the fact that the square root of 20 simplifies to 2 square roots of 5 because it's 4 times 5 and the square root of 4 is 2. So therefore, if I rewrite all these as 2 square roots of 5, they would all reduce a little bit further. But that is just for you whenever you're checking either at the back of the book or whenever you're checking on a device, what have you. a lot of times the simplified answer is what we're going to be looking for.
So this would be 2 square roots of 5 over 6, or square root of 5 over 3.
So if you were checking, cosecant then would actually be 3 over the square root of 5. And we could go ahead and change all those, but that is more a technicality as far as simplification. We're just going over the trigonometric process here at the beginning. Let's look at one more example. Sometimes they give you a right triangle, sometimes they give you a statement. So here it says cosine theta is 5 over 13. So I'm given that value of the fraction, and I have to find the other 5 trig functions. My recommendation is from here, draw ourselves a triangle. I like to have my orientation like so. You can draw it any way you want. On here, I'm going to label that this is my theta. If this is theta, cosine is adjacent over hypotenuse. This is 5, this is 13. I recognize this as a Pythagorean triplet. That tells me this side here is 12. If I didn't recognize that as Pythagorean triplet, I would take 13 squared, which is 169, minus 5 squared, which is 25. 169 minus 25 is 144. Square root of 144 is 12. From here, now I have my triangle labeled. I could say sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, which obviously matches. And then tangents opposite over adjacent. From here, I can rewrite all the reciprocals. Cosecant is 13 over 12. Secant is 13 over 5. Cotangent is 5 over 12. So if they give you a triangle, use the triangle. If they give you a trig function, create a triangle to be able to come up with your side.